this is an overview of the layers of the cortex and its function. So insofar as you can see on the page, the top up here, which I think is slightly out of frame, right here, is going to be layer 1, and then we're going to go down 2, 3, 4, 5, 6. So each 2 lines is a layer. So right here, oh no, what would this be? Here is layer 6, here is layer 5, here is layer 4, here is layer 3, here is layer 2, and here is layer 1. Now, the fundamental point about having a column, a cortical column, is that there's a set input into the layer. This will be 1 column here, and if I remember correctly, it's something like 1/4 of a millimeter in thickness or something in that ballpark. But you've got some sort of input that needs to be processed, and it's coming in from down below. And this would be like, here would be the top layer of it. It'd be like the most external, the most distal from the limbic structures, I think would be a good way to put it. And if you were to lay out the cortex flat, like a piece of paper, this would be the top end and this would be the bottom. So it's coming up from down below. Information comes in, and the information we have in the textbook is about the thalamus, and that comes in to layer 4. And you'd have these collateral axons coming in from a single input, and probably actually there's going to be, in one cortical area, there's probably going to be multiple inputs that are happening here. And there's going to be some sort of summation of total input that will alter the output. And we'll say this, we'll draw arrows here so we can keep things straight. You'll just forgive me for only having a black pen right now, but let's try to differentiate what's happening here with some sort of visual. Now, you have an input, and it has to be processed in some manner. Now, the things that process it are going to be local inhibitory and local excitatory cells. There are a couple of different kinds. The local excitatory local circuit neurons, meaning they're local to this cortical column, they don't project to anywhere fancy, are called spiny satellite cells, and they're little guys that don't have very complicated arrangements of their anatomy. So like they might have a little cell body, and then maybe they'll project to a couple dendrites here and a couple here, and we'll just say that's it. And they don't have these would be axons, so they'd probably have one axon leaving that would go here, 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 and let's call these dendrites because I already drew them, and say that they're going down here and then also interfacing with these guys from the thalamus. But the idea is that they don't have many places they're getting input from, and therefore they're high resolution. They do a very precise kind of processing that isn't influenced by a bunch of different systems. It's going to be highly contained to a small amount of signal. And then the local inhibitory neurons are going to be GABAergic, and there are multiple kinds. Let's see. They're called aspiny or sparsely spiny non-pyramidal cells. And the lack of spines refers to the lack of dendritic complexity. So if you have a cell with a bunch of spines and it's got some sort of massive amount of potential places to get input from and is summating a bunch of signals, it's a very spiny cell that's getting it's putting out feelers in a lot of different places. But in general, the local circuitry here is done high resolution with very precise wiring. And let me see what the name of these guys are. Hmm. So there are actually a lot of different kind of, let's put a plus sign on this guy. He's excitatory, and then there might be several local inhibitory ones. But the inhibitory ones have a lot of different names, and it depends on their morphological features, and there's no consensus on how they should actually be classified, whether it's by morphology or by function, in terms of like the actual output or the cell features of like the surface cell proteins. But the basic idea is that there are local inhibitory cells, and some of the names are basket cells, double bouquet cells, chandelier cells, and I think these are all local inhibitory cells. Now there's input coming in, and there might be a whole network of cells that are kind of talking. So they have an inhibitory one talking to this cell, sending an axon here. And then inhibitory one, so it's also talking to this one, sending an axon here. And then the excitatory one is talking to some things down around here, sending axons here. And then here would be a pyramidal cell, and its cell body would be like, I'm just gonna draw it as a pyramid and hopefully not confuse the point of the arrows below. But the pyramidal cell is going to have one main output axon that will escape, and that will be the output signal. And this would be its cell body, pyramidal cell, and it would have a reasonably large amount of dendrites. It's getting signal from various places and deciding whether or not to fire. And the nuances of the circuit here are found in the layer, where the layer 3 would fire to across the corpus callosum, and layers, the higher layers like layer 2, if you found a pyramid cell here, would fire to other cortical areas. So this would be to the cortex. This would be to the colossal areas, callosal. And those in layer 6, say here, would be firing to the thalamus. And from layer 5, you get all kinds of fun things. You'd have spinal cord, pons, medulla, tectum, thalamus, and striatum areas, and to a lesser extent also cortical areas. But this is, it seems like it's doing limbic and spinal kind of feedback. Let's see. So there's the picture I showed you from my neuroscience textbook, and the basic idea I've captured here is in here you'd have, I should write just subcortical sites in general. And when this fires, it's an excitatory output. The pyramidal neurons are always excitatory, and the output of a cortical column is therefore excitatory in the way it innervates other areas. Now, you have multiple areas that will be output from as a summation of the circuitry here, and the realities of the circuit are determined by the particular wiring of the GABAergic and glutamatergic interneurons, which are in general aspiny and dendritically simple. They don't have a complex tree of branching. They are going to have a pretty simple job, so that if there's incoming signal, and say there's an inhibitory one, it's going to go inhibit this guy, and if there's an excitatory one, it's going to say excite this guy and excite this guy. And they're going to be, I'm sure, more complicated wirings as you start to attach, if plus and plus here are attached to a minus, and this minus will only fire if both pluses are activated, and then that'll go inhibit this guy. You can get all kinds of crazy wirings, and I haven't looked into that. I don't know if anybody actually knows that. But the basic idea of the cortical column is you have an input from subcortical area, and well, it could be cortical, but either way, it's coming from down here. And then there's processing due to local neurons, and then there's output, which is excitatory from pyramidal cells, and its function or its destination is determined by its place in layering, and this is a function of the sequence of when things are wired up in development. And that's my basic understanding of a cortical column.